Hi scientists, I'm here to just walk through setting up for the Newton's second law simulation assignment. So you should have your instructions up. This is also where you're going to write down data and information and notability. But I'm just going to walk you through what it should look like when you get to the site. So when you click on the Here button right here, it will open up another window, and it will look like this. So first you want to select acceleration, okay? And you click again and it opens it up. Okay, and then we're gonna go to this green box right here. You wanna have forces clicked, values, masses, speed, acceleration, and then change our friction to none. Okay, so make sure you have your settings like that. Then it says, keep just the wood box for your mass. So here's our wood box. It's 50 kg, which is kilograms, right? That's our unit. And then it says to press pause. Okay, so you want it to look like the play button or the skip to the end. You do not want it to look like this. All right, then we are going to set the force using our arrows. So here's our force in newtons, that's our unit. We abbreviate that with an N, right? Capital N. So we're gonna use these arrows. So these arrows right here is what changes our force. So we can have 0, no force at all. We can be pushing to the left and have negative force, right? Or we can push to the right and have positive force. All right, so you can use this button. It's a little easier than this blue one down here. Then you're gonna record your acceleration value. So that's up here in the sky by the cloud. Your acceleration value right now is 0.00 meters per second squared. And this changes once we actually go and start, okay? So I'm gonna show you test number 1. And then test number 2, just to get you going, and then you'll do 3 and 4 on your own. So set the force value as seen on the table. So that's with these buttons. So 0 newtons, right? And if you press play here, right, our speed is 0, right? Our acceleration 0, because our force is 0. So that's already filled out in the table for you. Okay, then what you do is you want to hit pause after you're done with the test or the trial. So then we're going to increase to 100 newtons, okay? And then we're going to watch and see what happens to our acceleration. Okay, so now we see our acceleration isn't 0 anymore. Okay, our acceleration changed. So we're going to write down 2.00 meters per second squared in this box for 100 newtons. Okay, then we pause it, and you can change it for 3, and you can change it for 4. Then you're going to answer some questions about what you saw and the information here. So 9 says, how did increasing the force, let me change the force here, what happened to our acceleration? And you're going to complete this sentence. As the force increased or got bigger, the acceleration, and you have some choices here, increased, decreased, or stayed about the same. And you're going to write whatever your answer is here. Then you're going to do a little more writing. Write 2 sentences about how acceleration changes when you push an object with a strong force and when you push it with a weak force. Pick any object. So you're going to, in your house, pick any object. A pencil, I have a pen, okay, a toy, a book, etc. And you're going to push it 2 different times. Okay, first you're going to push with a strong force. Lots of muscle, right? And the second one, you are going to push with a weak force, just a little baby weak force. So I would write at home, when I push a pen stronger, it moves, and you can decide fast, slow, with a big acceleration, with a small acceleration, describe using one of those how it moved. And at home, when I push a pen weaker, it moves. And you want to push the same object, right? You want to make sure it's the same object with the same mass, because we know mass changes our acceleration. Hey, look at that. How does changing the mass change the acceleration? So we're going to go back to our simulation here, okay? And we want to test this by keeping our force the same this time and changing our mass. Last time we kept the mass the same and we changed the force. Okay, so our mass over here, we're going to adjust our object. Okay, so we want 500 newtons of force. Okay, and the first object we want to use is this person here. They're 40 kilograms. They're going to sit. Okay, so we go all the way up to 500 newtons, and you're going to press play and see what your acceleration is. This acceleration number you're going to write into this box here. Then when you're done, hit pause, and you're going to switch out the person for the box. Go up to 500 newtons again, and hit play and see what acceleration does. And you'll fill in this whole table. All right, so you want to pause and do that. Then when you get done, you're going to answer some questions and write a few things. So how did increasing the mass, so we went from 40 grams to 50 to 100 to 200, how did it change the acceleration? So as the mass increased, went up, the acceleration, what did it do? Did it increase, did it decrease, or did it stay the same? You're going to look at your numbers here. Then, at number 13, you're going to pick two different objects that are different masses, right? Two sentences about how acceleration changes when you push objects with different masses. Push an object with a lot of mass and push an object with a small mass. You can pick whatever objects you want. So let's say I could do a heavy object could be, I don't know, this desk that my computer's on. So I could push with about the same force, try and push and keep your strength, your muscle work the same, right? Your force the same. So what happens when you push a heavy object? So I would say at home when I push on a desk, it moves. Does it move fast, slow? Is there big acceleration or small acceleration? And then I might use the pen again because it's pretty small. At home when I push on a pen with the same force, it moves. Does it move fast, slow, big acceleration, or small? So you're going to fill all those in when you're all done. Make sure you get it turned in to Schoology, and make sure that you have everything complete before you turn it in.